So today we are going to learn Rutherford's atomic model. So before we get into learning, here are the questions which you will be able to answer by the end of the class. And these questions I have taken from the previous year IIT exam papers. Okay, so starting with the topic, we are going to learn Rutherford's atomic model today. So before we start learning, I have some questions for you. Tell me, who discovered protons? Okay, so I want some answers. Yes, E. Goldstein is the right answer. And who discovered electrons? Correct, J. J. Thomson is the right answer. Okay, and who discovered the neutrons? Yes, it was James Chadwick. So here's the timeline. If we look at it closely, protons were discovered in 1886 and then came the electrons in 1897. And further we had the discovery of the nucleus by Rutherford, and we will learn about it in detail today. And further, neutrons were discovered in 1932. So, when Rutherford was conducting his experiments, the known model at the time was based on the protons and electrons. And this was Thomson's atomic model. So any one of you who wants to explain this Thomson's atomic model, raise your hands. Okay, in Thomson's atomic model, the atom was a positively charged sphere in which the electrons were embedded. Okay, so here you can see the electrons are embedded on a positively charged sphere. Okay, and hence the electroneutrality was explained by the Thomson's atomic model. Further, Rutherford around 1911 started conducting experiments. Okay, and this experiment was the Rutherford's gold foil experiment. What he did in this experiment, what were the observations, and what conclusions he drew? Let us learn about it. Okay, so he conducted an experiment where the alpha particles. What are the alpha particles? These are the doubly positively charged helium ions. Okay, so He2 positive. So doubly positively charged helium ions. So these are the alpha particles. So a ray of alpha particles was used to bombard the gold foil. Why gold foil? Why not silver foil or aluminum foil or anything else? Why gold foil? Because gold is highly malleable. So any one of you who wants to explain what is malleability? Okay, that's great. So malleability means we can beat a metal into thin sheets, and gold is highly malleable. So we can get a sheet as thin as 1000 atoms thick. Just think about it, how thin it is going to be. Okay, so we had this gold foil and the alpha particle beams was bombarded on this gold foil. What were the observations? The observations were surprising. So what happened? Most of the alpha particles, most of them went straight through the gold foil and were detected on the screen. Here is the screen, you can see. Okay, here is the screen. Most of them went undeflected. Okay, so this was not what was expected. We expected this is the atom, and if we are going to bombard it with alpha particles which are highly energetic, they will deflect back. But that didn't happen. Most of them went straight through the atoms. Okay, so that was a shocking or surprising observation at the time. So yes, and this observation no one could explain using the Thomson's atomic model. So there was a need of a new atomic model. Okay, so that was the there was a need for the new atomic model, and hence Rutherford came forward with the new atomic model. So what he said that according to the observations, most of the alpha particles went straight through the atoms. That means most of the space in the atoms was empty and very few particles. Okay, so take note of it. These are the positively charged particles. So very few of alpha particles were deflected through small angles. That means the positive charge was occupying a very little space inside the atom, because positive charges repel each other. Okay, so that means the positive charge within the atom was occupying very small space. Further, as small of a number as 1 out of 12,000 particles, alpha particles, appear to rebound. They were deflected 280 degrees. Okay, so that means the entire charge and the mass was concentrated within a very small space, very small volume within the nucleus, within the atom, and Rutherford called it nucleus. Okay, and hence we discovered nucleus. Rutherford discovered nucleus. Okay, so now we have the knowledge of the nucleus. So using this nucleus, which has the positive charge and almost the entire mass of the atom, we are going to make a atomic structure. Okay, so Rutherford suggested that most of the space is empty. Okay, so he also did the experiment. After the experiments, he also did the calculations, and after the calculations, he concluded that the nucleus occupied as a small space as 10 raised to the power 5 times smaller than the entire atom. So you can just think about the ratio. So the nucleus is 10 raised to power 5 times smaller than the entire atom. Okay, so here is the nucleus and most of the space is empty and the electrons are moving, revolving around the nucleus in these shells. Okay, so that is the Rutherford's atomic model. But here's the problem, here's the drawback. What is the drawback? The drawback is that whenever we have any charged particle and it is moving, okay, it is moving in a circular path, so it must undergo some acceleration. Okay, so any charged particle undergoing acceleration must lose energy, and that means these electrons were going to fall on the nucleus. What does it mean? It means the entire universe will not exist, because all the electrons will fall on the nucleus and no atom will exist as we know of it. So he could not explain the stability of the atom, and hence we moved to the next atomic model, which was Bohr's atomic model, and we will learn about that in our next class. Okay, so after learning this much, let us get into the questions. So here we have question number 1. Rutherford's experiment on scattering of alpha particles showed for the first time that the atom has A electrons, B protons, C nucleus and D neutrons. I hope you are able to answer it now, and the right answer is option C, nucleus. Moving on to the next question. Rutherford's scattering experiment is related to the size of the option A, nucleus, B, atom, C, electron and D, neutron. Okay, so here again we know the answer, and the answer is option A, nucleus. Okay, so this was it from my end for our today's class. I hope you enjoyed the class and you learned the Rutherford's atomic model. Have a nice day. Thank you.